Assalamu alaikum, guys. Okay, so I've decided to make a few videos on your past paper questions. So this is basically a paper from your past, paper one of 2009 May June, and it's basically the chemistry paper that I'm gonna do the first 10 MCQs in this lecture, and then in the next lecture, the link of which I've given in the description, I'll be doing the next 10 and so on. All right, so now let's get started with the first question. Okay, so it says that the use of the data booklet is relevant to this question. In leaded petrol, there is an additive composed of lead, carbon and hydrogen only. Okay, only these three compounds are present: lead, carbon, hydrogen. This compound contains 29.7% carbon, 6.19% hydrogen by mass. What is the value of X in the empirical formula? Okay, a pretty easy question on empirical formula. All we need to do is just find the mole ratios and the simplest ratio and then the value of X. So I've done it over here in this blackboard as you see. Right, so lead, carbon, and hydrogen. The carbon and hydrogen have a percentage of 29.7 and 6.19%. If we add them up and subtract from 100, we'll get the percentage of lead, which turns out to be 64.11%. Okay, now using these percentages, we can calculate the mole ratio by dividing them by their respective ARs, atomic masses, relative atomic masses. Relative atomic mass of lead is 207.2, so 64.11, which is the percentage, it gets divided by this to give us 0.31. And similar result, we do the same thing over here for carbon divided by 12, for hydrogen divided by 1. All right, now after getting the mole ratio, what we'll do next is that we'll get the simplest ratio. Now to get the simplest ratio, we'll divide all these three terms by the smallest of these three. Okay, so 0.31 is the smallest of the three. Divide 0.31 by 0.31, divide 2.475 by 0.31 and 6.19 also by 0.31. So we get 1 is to 8 is to 20. Okay, the question says PbC8HX. Okay, it also says that PB C8 and HX, and what we got is PbC8 and H20. So the value of X equals 20. So 20 is our answer. Right, so for this one, it's D, the first question. Right, now moving on to the next one. A household bleach contains sodium chlorate 1. This is the disinfectant that is used as an active ingredient in household bleaches. The concentration of sodium chlorate 1 in bleaches can be determined by reacting a known amount with aqueous hydrogen peroxide. Alright, so we react NaClO with hydrogen peroxide, we get NaCl, water, and oxygen. Alright, now when 25 cm cube of the bleach is treated with an excess of aqueous hydrogen peroxide 0.035 moles of oxygen gas is given off. What is the concentration of sodium chlorate? Okay, for such question which involves stoichiometry, we use the stoichiometric equation and the mole ratio is given in there. If we look at oxygen and sodium chlorate's mole ratio, it's 1 is to 1. So this means that if the whatever the moles of oxygen are, the same would be the moles of sodium chlorate 1. The moles of oxygen as given in the question are 0.035. We'll use it to calculate the moles. Okay, so they are going to be the same as the moles of sodium chlorate 1. The formula for concentration in mole per dm cube is concentration is equals to moles divided by volume. Okay, volume must be in dm cube because it's given over here, moles per dm cube. So now over here, when 25 cm cube of the bleach solution, the volume in the question is 25 cm cube. So we divide 0.035 by 25 and multiply the whole thing by 1000 to get our answer, which is 1.4 mole per dm cube. We multiplied by 1000 to convert it into dm cube, and so D is our correct answer. Then moving on to the next question. Question 3. It says that the first 7 ionization energies of an element between lithium and neon in the periodic table are as follows. Okay, these are the first 7 ionization energies. First ionization, second ionization, third, fourth, fifth, sixth, and seventh. All right, what is the outer electronic configuration of the elements? Okay, for such questions, the trick is that we need to search for the biggest increase in the successive ionization energies. Over here, the increase is okay-ish, okay. All right, now the increase is increasing, but like not much. Okay, it's increase, but the largest increase is in between these two values, 13,300 and 71,000. This is a very large increase. Okay, and if we look at the successive ionization energy at which this occurred, it's between the sixth ionization energy and the seventh ionization energy, right in between the sixth and the seventh. All right, now between the sixth and the seventh, a shortcut to this is that you just take the first ionization energy from where the jump is, from where the ionization energy there is a from where there is a very big jump in the ionization energy, and from here you just give this is actually the group of the element. This gives us the group of the element. So if it's 6, so this means in Roman numericals it's 6, it's in group 6. And for elements in group 6, they have 6 electrons, 6 valence shell electrons, and for 6 valence shell electrons, C is the suitable answer. 4 plus 2 gives you an answer of 6. Right, now moving on to the next question. Okay, question number 4. Use the data booklet in relevant is relevant to this question. Okay, which graph represents the number of unpaired p orbital electrons to the for atoms with the proton numbers 13 to 18? Okay, the question says unpaired p orbitals. Okay, now this is important. Unpaired p orbitals. Okay, p contains a maximum of p subshell contains a maximum of 3 orbitals, px, py, and pz. This means that if we increase, okay, 13th. For the element with proton number 13, this p orbital contains only one electron. As we increase, the second electron is added to the next one, and the unpaired electrons are actually increasing, and it increases till the 15th one. Right, the unpaired electrons, they keep on increasing till 15, because till 15 all the three are filled singly, and they all of them are unpaired. But after 15, when we go on to the proton number of 16, then pairing starts. First electron comes and pairs with the first one. So the number of unpaired electrons actually decrease after 15. And then they decrease and reach 0, because now all of them are filled and no unpaired electrons are present. Now let's see which option matches this answer. All right, so first one, it's increasing, so this cannot be the answer. It's decreasing only, cannot be the answer. We need to search for an answer option in which there is both an increase and a decrease. There is an increase here, but a constant steady, no, only D is our answer. Okay, there is an increase till 15, and then there is a decrease to 0. Now moving on to the next question. 5. Which statement explains why the boiling point of methane is higher than that of neon? Alright, basically over here, if you compare methane molecule with neon, both of them are non-polar, so the main intermolecular force that exists in between them are the van der Waals forces. Okay, you guys need to know one thing, that the boiling points or any physical quantity depends upon the strength of the intermolecular forces and intermolecular forces alone. Okay, not the chemical bonds, not the intramolecular forces. Okay, so this would mean that methane has a higher boiling point, because obviously its van der Waals forces are stronger because of its higher MR and higher number of polarizable electrons. So now let's check out the answer options. A molecule of methane has a greater mass. Okay, this can be a possible answer. Now, molecule of methane form hydrogen bonds, but those of neon do not know. Methane does not form hydrogen bonds. Molecules of methane have stronger intermolecular forces than those of neon. Yes, definitely. This is the correct answer. They have directly talked about the intermolecular force. Although A could have been an answer, but it's indirect. It's just talking about the mass. And this over here in option C, they are directly talking about the intermolecular forces. So yeah, C is the best option. A molecule of methane is polar? No, not at all. Right, it's not. It's non-polar. Okay, question number 6. In which reaction does the carbon-containing product have a smaller bond angle than the organic reactant? Okay, first one, it says that bromoethane reflux with ethanolic sodium hydroxide. Okay, this is bromoethane molecule. If we react and reflux it with sodium hydroxide, it's actually a nucleophilic substitution reaction, and in this case, it's SN2 mechanism, because we have a primary alkyl halide. Now, if we do this OH will replace the bromine, and there will be no change in the bond angle. The bond angle initially was 109.5 because of the tetrahedral shape, and now also it's 109.5, so no change. So A cannot be the answer. Then if we talk about B, the complete combustion of methane in air. So if we completely combust methane in air, we'll get carbon dioxide. Carbon dioxide has a larger bond angle. Then, if we talk about methane and an excess of chlorine under ultraviolet light, again, this is a free radical substitution and no change in bond angle would occur. The bond angle initially would stay 109.5, and immediately after the reaction, it will still stay 109.5. And polymerization of ethene, yes, this is the correct answer because ethene is an alkene and alkenes have the bond angle of 120 degrees. These 120 degrees after polymerization will form a polymer or an addition polymer of this alkene, and yes, the addition polymer has a smaller bond angle of 109.5 degrees. Okay, now moving on to the next question. 7. Crystals of iodine produce a purple vapor when gently heated. Okay, which pair of statements correctly describes this process? Okay, guys, again, this is a physical change, property that has been discussed. Okay, so if anything is changing its physical state, then the covalent bonds cannot be the answer because they are the intramolecular forces. We need to look at the intermolecular forces. If we look at induced dipole and permanent dipole are two possible answers, but since we know that iodine is non-polar, so permanent dipole cannot be the answer and only C is the correct answer. Right, now if we look at the option 8, over here hydrogen peroxide slowly decomposes into water and oxygen. The enthalpy change of the reaction can be calculated using the standard enthalpy changes of formation. Using a Hasse cycle, what is the enthalpy change of the reaction for this decomposition? Alright, we are given the enthalpy change of formation of hydrogen peroxide and enthalpy change of formation of water. If we review, if we take a step back and revise what enthalpy change of formation was, enthalpy change of formation was actually the enthalpy change that when 1 mole of a compound was formed from its elements under standard conditions. All right, but anyways, we don't need to know the definition over here. All we need to do is we need to draw a Hasse cycle. But a shortcut before drawing a Hasse cycle is that whenever we are given formation data for formation, and we are asked to calculate the enthalpy change, this is the overall reaction, the equation that we should use. This is just a shortcut, a short trick. Okay, enthalpy change equals the sum of enthalpy changes of products minus sum of enthalpy changes of reactants. Okay, so sum of enthalpy changes of products. The products that we have are water and oxygen. Okay, since there are 2 moles of water, so we'll multiply it by 2, the enthalpy change of formation of water, which is minus 285.8, plus enthalpy change of formation of oxygen. Oxygen is an element, and elements have zero enthalpy change. All right, the whole thing comes in brackets, and there is a negative sign over here, and then enthalpy change of reactants. All right, sum of enthalpy change of reactants. Okay, there are 2 moles of H2O2, 2 moles of hydrogen peroxide. So 2 moles of hydrogen peroxide would mean that you just multiply this enthalpy change of formation of hydrogen peroxide with 2 and you'll get an answer with the correct sign of minus 196 kilojoules per mole. Right, so C is the correct answer. So always remember for enthalpy change of formation data, whenever you are asked to calculate the enthalpy change, it's the products minus reactants and also multiplying the enthalpies by their respective moles. Okay, now question number 9. All right, so when a copper is extracted from its ores, the metal is not pure enough for electrical uses. The impure copper, which contains small amounts of silver and gold, is purified by electrolysis. Okay, electrolysis is a technique of purification that you guys all are already familiar with. Okay, during this process, a sludge forms beneath the anode, which is found to contain silver and traces of gold. All right, so silver and gold is found in these traces. Silver and gold is found in these traces below the anode sludge. All right. So what is why is silver formed in this sludge? All right. So in this case, what this is the setup. We have impure copper as the anode and pure copper as a cathode. We have copper sulfate or any copper compound as a solution. So when current passes through this solution, so what happens is that the copper ions and silver ions, they both try to lose their electrons. But since copper can lose electrons more readily than silver because copper is more reactive, so therefore it forms copper 2 positive ions and silver does not form any ion. It stays in atomic form and it falls to the bottom. Right, so this ability to lose electrons is known as electropositivity of the metal. And since electropositivity of copper is greater than the electropositivity of silver, A should be the best option because silver is less electropositive than copper, so it cannot lose its electron more readily than copper and so cannot form its ions. And so fall to the bottom in atomic form. Then MCQ number 10, the diagram shows the Maxwell-Boltzmann energy distribution curve for molecules of a mixture of two gases at a given temperature. Okay, for a reaction to occur, the molecules must collide together with sufficient energy. Yeah, and that energy is actually your activation energy, or if the molecules possess energy greater than the activation energy, only then will the reaction occur. This is what Maxwell-Boltzmann or the concept of activation energy tells us. Now, if we look at this graph over here, this on the y-axis we have the number of molecules labeled, and on the x-axis we have the energy labeled. Always remember, okay, EA is the activation energy for the reaction between the gases. Activation energy is the lowest energy needed for the reaction to occur. Of the two values shown, one is for catalyzed and the other for uncatalyzed one. Which pair of statements is correct when a catalyst is used? Okay, catalyst is used actually. All right, so catalysts actually have the role of providing an alternative pathway for the reaction to proceed. And since it provides an alternative pathway for the reaction to proceed, that alternative pathway which it provides have a lower activation energy. And since it lower that the pathway has a lower activation energy, so more molecules are more likely to have a higher activate have higher energy, have kinetic energy greater than the activation energy, so they'll collide with sufficient energy for the reaction to occur. So now over here, what's happening is that one of the reactions have a higher activation energy and the other has a lower activation energy. So let's look at the statements one by one. EA1 is catalyzed reaction. Okay, higher and lower activation energy. On the basis of the catalysis, we know that the lower activation energy belongs to the catalyzed reaction, right? So EA2 is your catalyzed and EA1 is the uncatalyzed reaction. And if you have a lower activation energy, that would mean that more molecules have a kinetic energy greater than the activation energy, and so the reaction can proceed swiftly. So now let's look at the answer options one by one. The first one says that EA1 is the catalyzed reaction, fewer effective collisions. EA1 is not the catalyzed reaction, or is it? Let's check it out. EA1 is actually the uncatalyzed reaction. It's the uncatalyzed reaction, okay, because it has a higher activation energy. So A cannot be the answer. Now what about B? EA1 is the uncatalyzed reaction, so it has fewer effective collisions. Yeah, true. And EA2 is the catalyzed reaction, so more effective collisions. Yes, correct. So B should be the answer, right? Since more effective collisions are present in the catalyzed reaction, as the molecules have energy greater than as more molecules have energy greater than the activation energy. Okay, so that was it in for this today's lecture. For this lecture, all right. So I've given the link to the next lecture, which contains MCQ number 11 to 20. Okay, in the description, do check that out, please, because the paper is in continuation. Thank you so much.